Okay, this is an introduction to the actual processor. We've done 2 layers so far of hardware. We've done the outside, which is the stuff to do with doing peripherals. That's where the keyboard, mouse, all the stuff for getting information in and out of a computer system or storing it for long-term use. We did that previously. Then we've also done a section which was on the internal components on a computer system, which basically comes into having some form of input-output, which is normally controlled through these USBs, the PCI bus. There's often a secondary storage, but we normally have a computer consisting of input and output, which is done across these buses, a processor, and various forms of memory, RAM or ROM. And now we're going to actually go into the inside of the CPU and have a look and see what happens in there. So some of these have different names in different places. I'll try and remember some if we go through. What we have inside the computer is a series of circuits that, depending on an instruction code, connect different circuits together to perform a task. So the way it works is we have a memory interface. Different computer systems like Harvard, you could have 2 memory interfaces, one for program and one for data. Or you've got the more common system, which is the von Neumann system, which uses a single memory interface interfacing to RAM or ROM information to be able to process get the program instructions and the data. And we're going to look at it from a von Neumann side. So what we have is we have an instruction system which consists of the program counter. That is a register. A register is just a piece of memory, very fast memory that's stored within the processor itself. It's got its own set of values. The program counter says where to go and get some information from. The memory interface will then pull down that instruction that's at the program counter, and quite often a bit of data with it as well. And the instruction decoder then works out what needs to be done by holding that instruction in a register. So we've got the current instruction register, so that different circuits can be connected. It also may request that there's further information received into the memory as well. And what can happen is that when we come in here, we might need to actually access memory to its address and the memory address register. So if I want to go to a certain location, I use the memory address register, and that connects up that particular piece of memory. And the memory buffer register, or the memory data register, this often has 2 now. Some people say one thing, some say the other. And this stores what's actually currently in the memory or about to be written to the memory at that address. Those registers all control what's going to happen. And what happens is they pass the information and set up the registers and pass the status into the ALU. So the instruction decoder then chooses what operations need to happen. Are we doing a store? Are we doing an add, a subtract? Are we doing a check? And it uses those circuits to perform a calculation. And the result of that calculation is often returned in what's called the accumulator, or associated with that, it can change a series of status registers, which hasn't been put on this diagram. And the status registers can say that there was something called an overflow, the number was too big, or you tried subtracting something that was too big, so we've got a negative overflow. It could say we've got a 0 value, and those little indicators can come back into the register for the program to work. So these are the sections that work. The accumulator is the result. The memory interface talks to a piece of memory controlled by the memory address register, and stores the information in the memory buffer or memory data register. The instructions are controlled by the program counter and the current instruction register. And various commands can affect various registers. The program counter generally just counts up based upon what the last instruction was. It knows how many bytes are needed to store the current instruction, and then it can work out, oh, I need this move on so many points for the next command. Some commands might tell the program counter, though, to go to another place. They're jumps and branches and if statements, basically. So we'll just have a quick look at a program and see how they interact. So starting off, we'd use the program counter to say where we are in the program, and we're going to go to the start, memory address 0. The instruction fetcher will go and get the instructions needed from that address. So this will actually pull down an instruction 1A, which is a load command. That means get a number into the accumulator. And it's a particular one which says from a memory address. And this is memory address 10. So the program fetcher gets into the current instruction register the code, the load, and it also instructs the memory interface to go to memory address 10. And the memory address 10, if you look at memory address 10, it brings back the number 4. So the MBR, or data register, will now have 4 in it. Everything's now set up for this to do the next statement. So the instruction decoder now tells the ALU that the instruction is take whatever is in the memory data register and store it back into the accumulator. And the accumulator is where it stores its normal results. That's completed. The program counter now moves on to the next command, and it knows that a load command has used 2 bytes, so it moves on 2 places to memory address 2. That tells the program instruction fetcher to go and get the instruction, gets 27 back, and then as it programs that into the instruction decoder, so the current instruction register now contains the 27, the ADC command, it knows it also needs to go to another memory address. And this says go to memory address number 12. Memory address number 12 contains the number 3. So memory address 12 on the MAR will contain data number 3, and that will sit on the memory interface. Now the instruction decoder says we're ready. It tells the ALU perform instruction 27 ADC, and that's an add with a carry. All it means is it's going to take what is currently in the accumulator and add to it whatever's on the data register. It adds them together, giving me 7, and puts that back into the accumulator. So my accumulator now contains 7 from doing 4 plus 3. Program counter moves on. I've had to use 2 bytes, so it moves on 2 more bytes again. Goes memory, tells the instruction fetcher to go to memory address number 4, get the instruction number 29. Current instruction decoder goes 29. Oh, I need to program the memory interface as well. I need the memory location 10 set up. So memory address is set to 10, and the MBR will say what's in the 10 as well. And then when it triggers into the ALU for this command is to say store the accumulator in this memory. So now this will do the opposite of the first command. It will take the value from the accumulator and put it into the memory buffer register or memory data register. The instruction completes. The memory interface puts it back, and now what we will have is at the end, this number will not be a 4, it will now be 7. We'll have changed that memory address to contain a value 7, the sum of the 4 and the 3 that we began. And that's what how a processor works. What can happen sometimes is if this had got to be too big, so it went to, say, 270, it's too big for 1 byte, the accumulator might throw an error and say overflow. And this overflow might say branch on overflow, which says change the memory address. So you could get instructions that will change the program counter. So that's the sorts of things that a processor will do. So in summary, what we have is an instruction fetcher and decoder section. Sometimes they're grouped together as a control unit. They create an instruction and store it in memory. They start breaking down what other information is needed. The current instruction register contains the current command being executed. The command is told where to be from the program register, the program counter register. The registers, if they need to use the memory interface, they talk to which piece of the memory they want to the address register, and the value is exchanged using the memory buffer register or memory data register, and that acts both ways to the memory. The arithmetic logic unit is actually the circuitry that moves things around physically, or does an addition or does a subtraction, and that actually will turn around and normally will communicate through an accumulator is its normal result. Here's the answer to the last command. It can do other things. More complicated processors can have multiple registers, and different registers interact with each other, but that means we often need more commands or we need more codes, and that can make the processor more complicated. So this is the basic structure. Okay, you need to make notes on all those sections. You don't have to do an example of what the program is doing. That was just put in there so that you could actually see each part has its use. Okay.